All right, part D. So we've got an outside function that looks like the natural log of x, and an inside function that looks like 1 over 5x to the 6th minus 15x to the 4th plus 4x minus 2. Okay, derivative of the outside is 1 over x. Derivative of the inside, this is just, oh, and I don't know why I put 1 over. It's not 1 over. My bad. 5x to the 6th. The derivative of the inside is 30x to the 5th minus, let's see, 60x cubed plus 4. Right, 6 times 5 is 30, 15 times 4 is 60. Okay. So then putting it all together, the derivative of y prime is going to be the derivative of the outside with the inside plugged in. And then times the derivative of the inside, 30x to the 5th minus 60x cubed plus 4. Okay, part E. This looks like a quotient rule problem. I have a top natural log of 2x plus 1 and a bottom of 3x. And then the derivative of the natural log is going to be, so derivative of the top is 1 over the inside times the derivative of the inside, which is just 2. So, okay, that's just 2 over 2x plus 1. So to find the derivative of a quotient is the bottom times the derivative of the top, which is 2 over 2x plus 1, minus, so bottom times the derivative of the top minus the top times the derivative of the bottom, which is, oh, and I never did that. Derivative of the bottom is just 3. All over the bottom squared. Cool. Okay, part 3, or question 3, excuse me. On what interval or intervals is the given function decreasing? So this looks like a quotient again. Top is 5 natural log of x, and bottom is x squared. Okay, and then there's a hint here to think about where g of x is not continuous. So I'd actually go so far as to say is like, what's the domain? And this is useful to think about for when we're testing values. So I know x can't equal 0 because you can't divide by 0. And I also know that the natural log of x, we don't plug in negative numbers, so x has to be greater than 0. So this will help me when I do a number line, but for now, if I want to know where something's decreasing, I need to take the derivative. So I need g prime of x so that I can find critical points. So like I said, this is a quotient rule, so it's going to be the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. So that I'm going to simplify. So I've got an x squared and a 5 over x, so the x's should cancel and I get 5x. And then I have minus 5 times 2 is 10, so 10x natural log of x all over x to the 4th. So I need to look at critical points, and that would mean setting it equal to 0. So I'm only setting the top equal to 0 because if the bottom is equal to 0, that's going to give me something not defined. That's not going to give me something that's equal to 0. And I already know that I can't plug in x equals 0, but it's not in my domain, so I'm basically just going to set the top equal to 0 and solve. And I think the way I would do that is by factoring out a 5x. That'd be 1 minus, let's see, divided by 2 natural log of x. Okay, let me check my work real quick. So if I multiply by 5x, yeah, okay, that works. So then I would set each part separately equal to 0. If I have something times another thing equals 0, then I have to check both. But actually, I'm not going to worry about this because that's x equals 0, which I already know it isn't something in the domain even, so I don't really need to worry about it. So I'm just going to solve this second equation, and I'm going to start by adding 2x to the other side, then dividing by 2 equals the natural log of x. So I could raise both sides, like do e to the 1/2, and then e to the natural log of x is just x. So now I just put e to the 1/2 in a calculator. All right, e to the 0.5 power is roughly 1.65. So that's not enough right there. I still need to do like a little bit more to figure out where it's increasing versus where it's decreasing. So I've got a number line here, and the number line says it has to be things greater than 0. So not including 0, and then I have a critical point at 1.65. So I need to check here and all the way over here. So to do that, I think the best thing would be to check, let's see, maybe we'll start here. So the function that we started with was called g. So I need g prime of 1 and g prime of 2, because I'm just testing the points. So between 0 and 1.65, 1 would work. And if I plug in 1 into my derivative, which is here, I'm going to plug in all the way here at the right. That would be 5 minus 10 natural log of 1 all over 1. And I think the natural log of 1 is 0. But let's find out. Natural log of 1 is 0. So this actually just equals 5, which is positive. So I'll put a positive here to remind me. And then for g prime of 2, that would be 10. And I'm plugging it in right in here again into the derivative. So that would be 10 minus 20 natural log of 2 all over 2 to the 4th. And that's something I have to put into a calculator. I just have no idea. So 10 minus 20 natural log of 2, and then divided by 2 to the 4th, that is something negative. Equals negative. It doesn't matter what it is, it just matters that it is negative. So the question was asking where it's decreasing, so that's going to be from my critical point, which was e to the 1/2 power, all the way to infinity. That's my final answer. So this problem has quite a few steps that range from all different parts of this class. So if you're stuck on anything, let me know, because this type of problem is definitely something you might see on a test. Okay, ask questions on the discussion board.